In this example, there is a person who essentially is yelling into a cave. So we have a person, and then there's a cave, and somewhere back here there is a wall. And so the sound wave is going to travel, it's going to reflect off the wall and come back to the person. And we know the time it takes to go from here to here, and because we're given the temperature, and since I haven't given you any other indication, you're going to be on Earth, in Earth's atmosphere, and from that information you can get the speed that the sound wave travels at. So we can use that, using some information from topic 2, the idea that velocity equals distance over time, in order to establish how far it is to go from the person to the wall. So you can see here the first thing I did was calculate the speed of sound through air at 0 degrees Celsius. So I converted my 0 degrees Celsius to Kelvin by adding 273, so I plug that in here, and we find that the speed is 331 meters per second. So I plug in here velocity equals distance over time, and I plug in my speed of sound and the time, and I get this distance. Now you do have to be careful. That's the time for the person to yell, go to the wall, and reflect back. So that's the distance from the person to the wall and back. So we have to divide that by 2 to find the distance from the person to just the wall, and not the reflect back.